problem was to you. You're not my manager.
All right, hello. Is that better? Our final section in chapter 4 is all about solving exponential and logarithmic equations. To solve these types of equations, we're going to use a few of the different properties that we've been talking about over the last 3 sections. So, and for a lot of these problems, there's more than one way to solve them. Okay, I'm going to show you multiple different strategies. Okay, but for a lot of these problems, you could use a couple of the different strategies on them. Numbers 1 and 2. Okay, one property that we can use is if the bases are the same, then we can set the exponents equal to each other. Well, in this case, my bases aren't the same right now, but I can write both 25 and 125 with the same base. Okay? I can rewrite 25 as 5 squared. Right? So I could rewrite this as 5 squared to the x. And then I can also rewrite 125 as 5 to the 3rd power. So this would just be the same as 5 to the 2x. Right? If I've got a power to a power, I just multiply the exponents together. So now, if I have the exact same base, I can just set the exponents equal. Right? The exponents would have to be equal for this equation to hold true. So now we can just say 2x equals 3. Divide both sides by 2. We get x equals 3/2. We can do something similar for number 2. We can rewrite both 3 and 9 with the same base. So give that a try real quick here. We get 1. Okay. Any questions on this strategy? Okay, so this strategy is very specific to us being able to rewrite the bases as the same thing. Okay, that's not always going to work. It's not always going to. We're not always going to be able to do that. Okay, but if we can, okay, it gives us an easy way to solve the problem. For the next couple, the 3 and 4 here, we could actually still rewrite 16 with a base of 4, but I'm going to show you a different way to do this problem. For this one, we can lazy 7. Okay, whenever I have an exponential equal to a number, we can use lazy 7. So I can do log base 16 of 4 equals 2x. Log base 16 of 4 equals 2x. So now, this one we can actually evaluate without a calculator, okay? But we know how to use a calculator to get this number now. Okay, but what it's saying is 16 to what power equals 4? So can we do that without the calculator, or do we need the calculator? So I heard some rumblings that the square root of 16 is equal to 4, right? So that would mean 16 to the 1/2 power, right? Square root is the same as the 1/2 power. So 16 to the 1/2 power equals 4. So this would just be 1/2. Let's solve for x. Divide both sides by 2. So we would get x is 1/4. Okay. Now, lazy 7 is the shortcut here to remember what to do. But I want to show you guys what mathematically we're actually doing. Okay? Mathematically, we have to undo an exponential. We have to use an inverse operation. Well, the inverse of an exponential is a log. So what we're actually doing here is taking a log of both sides of the equation. Okay? So write this over here. So I've got 16 to the 2x equals 4. So what I'm actually doing is taking the log base 16 of both sides. Okay, so then we just said log base 16 of 4 is 1/2. Over here then, okay, one of the properties that we talked about was log base a of a just essentially cancels out, and that's equal to the exponent. The mathematical reason behind that, okay, if we use our power rule, I can bring this 2x out front, right, and write this as 2x times the log base 16 of 16. What's the log base 16 of 16? 16 to what power equals 16? 1. 1, right? So this is just equal to 1. So we just have 2x times 1. So 2x equals 1/2. And then we finish out what we just did. Okay, so this is the shortcut, right? Lazy 7 is the shortcut. But the math behind it is this. What we're actually doing is using an inverse operation, taking a log of both sides, and then using our power rule, saying we can bring that exponent out front, and this will just be equal to 1. Okay? So, try number 4 here. Okay? You can use the shortcut. You don't have to write it out as you're taking the log of both sides. What's up? I believe so. Yeah. Yep. Can't do that.
You just do some math.
Yeah.
Some math. You can't just multiply or like raise them to like 3 or 4. It might be.
Okay, I think we get 5/2 for number 4. Okay. Now, for 5 and 6, okay, these ones look a little bit different. On both 5 and 6, I cannot rewrite both the bases to be the same. And I don't just have an exponential equal to a number. I have exponentials on both sides of the equation. Whenever we have something like this, we are going to have to start by taking a log of both sides. It actually doesn't matter what base I use. So usually we just say take the natural log of both sides of the equation. Right? So I'm going to say natural log of 4 to the x plus 1 equals natural log of 3 to the 2x power. So now we're going to use our power rule that we just talked about. I can bring both of those exponents down. We can write this as x plus 1 times the natural log of 4 equals 2x times the natural log of 3. Okay, we can bring these exponents down. So now, to solve for x, I'm actually going to have to multiply this out. Okay, I'm going to have to multiply the natural log of 4 through. So I'm going to have x times the natural log of 4 plus 1 times the natural log of 4 equals 2x times the natural log of 3. Any thoughts on how we can get x by itself since I've got two x's here?
Get them on one side.
Get them on one side. And get the x's on one side, get everything else on the other side. Okay, so I'll subtract this 2x natural log of 3 over to the left side, and I'll subtract natural log of 4 over to the right side. So it'll look like x times the natural log of 4 minus 2x times the natural log of 3 equals negative natural log of 4. So now that I have all of my x terms on one side, I can factor x out. And we'll have x times the natural log of 4 minus 2 times the natural log of 3. Now, I can just divide both sides by this whole thing. We end up with x equals negative natural log of 4 over natural log of 4 minus 2 natural log of 3. Okay, the whole point of getting all the x's on one side is I can factor in x out and then divide both sides by this whole thing. Okay. Questions on something like that? Okay, now we could actually use this process on any exponential equation, right? But this is probably the most complicated way of doing a problem. So if you can recognize either of the shortcuts that we talked about in the first 4 examples, okay, that'll be beneficial. Okay, but technically we could start any exponential problem by just taking the natural log of both sides and using the power. Okay. Questions on that one? All right, let's take a minute or two and see if you guys can try number 6 here.
That's what I want to do.
I think on the homework problems it says give me the exact answer and then also give me like a 3 decimal approximation. So yeah, we will want to plug that into the calculator.
We just magically don't have homework for the first time. Yeah.
Okay, did we get -5 natural log of 3 over 2 natural log of 3 minus natural log of 17?
Seemed a lot harder.
So, pretty good on
Watching it right now.
okay. So any questions on these ones? These are probably the hardest ones. Okay, where we have to take the log of both sides.
Well, we don't need the exact answer on this right here.
Well, this is the exact answer. But then plugging into a calculator, we'll get a decimal approximation.
I see.
Am I good to erase it, sir?
Mr. Fetch, what is your secret?
Secret to what?
Just being Mr. Fetch.
I don't know.
You do it so effortlessly.
Thanks. So on the back then, okay, we can take a look at solving a few logarithmic equations. So in number 7, okay, the first thing that we want to do, okay, if I just have one log, I want to get the log by itself. So I'm going to start by subtracting 4 and then dividing by 3. Okay? So subtract the 4 over first. We'll have 3 log base 2 of x equals -3. Then divide both sides by 3. Get log base 2 of x equals -1. So now, I'm just going to rewrite this as an exponential. Okay, again, using that lazy 7 idea. So we're going to say 2 to the -1st equals x. What's 2 to the -1st? 1/2, right? This would just be 1/2 to the 1st power. So 1/2. What we're actually doing here, again, the lazy 7 is the shortcut. What we're actually doing, okay, once I get the log by itself here, I'm actually raising both sides to a power of 2. So I'm really saying 2 to the log base 2 of x equals 2 to the -1st power. Okay, so then we talked about 2 to the log base 2 essentially canceling out. So we would just get whatever's on the inside here. Okay, so that's mathematically why lazy 7 works. Okay, we're raising both sides as a power of whatever the base is here. So in number 8, I've got 2 logs. Okay, I want to combine these into a single log. How can I combine those into one log? Yeah, I'm going to multiply what's on the inside. Right, so this is going to become log base 3 of x times x minus 2. Yeah, we can. Yeah. So we can make this log base 3 of x squared minus 2x. Okay. So now, once I have one log equal to a number, I'm going to do the same thing I did over here. I'm going to lazy 7. So I'm going to say 3 to the 1st power equals x squared minus 2x. How do I solve this?
Negative 1.
Yeah, just get everything on one side. And then x factor. So two numbers that multiply to -3 that add to -2. -3, +1. So we would end up with x equals 3 and x equals -1. On a log, whenever I get my final answers, I have to plug them back in.
Do we have
We can have extraneous solutions for logs.
what if you only get one answer?
So we gotta plug it in. I don't care.
What if you feel like crying?
So, and we need to plug it back into the original problem. Okay, we can't plug it into any steps that we've had so far. We have to plug it into the original problem. And the only thing we care about is that we get positive values inside of the log. Okay, we don't have to check and make sure it's exactly equal, right? We're just checking to make sure we get positive values. So if I plug 3 in for x, well, that'll be a positive inside the log. Plug 3 in here, 3 minus 1, that's a positive value. So we're good. Okay, x equals 3. Bless you, it's an answer. If I plug -1 in for x, well, that's obviously a negative value inside of the log. If I plug -1 in here, also a negative value. That means -1 is an extraneous solution. Right? All we're looking for is whether we get a positive or negative value inside of the log. If we get a negative value, it's extraneous because we can't have a negative inside of a log. Okay? I'm going to skip number 9 because that's just an exponential that we would lazy 7. Right? We would say log base e of 5 equals 2x minus 1. But number 10, okay, there's two ways that we could solve number 10. Okay? One is using a strategy we just talked about, combining these into a single log using division. Right? So I could say log base 5 of 3x minus 1 over 2x plus 7. And lazy 7 and solve from there. Another strategy, okay? I could add this log over to the right side of the equation. And they cancel out. Right? So we could say log base 5 of 3x minus 1 equals, if I'm adding this over, log base 5 of 2x plus 7. If I've got log base 5 equal to log base 5, and two logs with the same base, I can just take whatever's on the inside and set that equal. So I can just say 3x minus 1 equals 2x plus 7. Subtract the 2x over, add the 1, we get x equals 8. Yes, we can. Yeah, that's a good question. We can only use that strategy because we had a 0 on this side. Okay, so this strategy only works if I have a log equal to a log. It does not work if I have plus anything else on the outside of the log. Okay, you okay with that one? Okay. I didn't put any word problems in your homework, so we're going to skip number 12. Homework's at the bottom.
I'm going to skip you.
28 to 38, and 66 to 69.